Hello, hello. Oh, working nicely. Hello.
Good. We have the start of our next block. The next block is 3 presentations on data, perfectly in line with the theme of this Brightcon, open data. And I welcome the first speaker, which is Conrad Spindler. He has graduated at the University of Luxembourg in physics and material sciences with a PhD, and now he's been working for more than 3 years at Green Delta, the developers of OpenLCA. And there he's leading research tasks and studies for sustainability assessment in Horizon Europe projects, but he also consults public and private customers. And also he supports the improvements of OpenLCA, as you've seen yesterday in the bar camp. He's looking for inputs and already doing a great job with this, and also implementation of eConvent into the OpenLCA cosmos. Welcome, Conrad.
We have a new microphone? Yeah. Okay, we still need to share, right, Chris? It's now the other monitor, right? It's like mirrored because of Excel presentation, PowerPoint presentation. How can I switch the Shall I mirror it? It is already mirrored, but when it's always the speaker's view. Is there a shortcut to switch? Yes. Yes, okay, thank you. So, okay. Okay, so OpenLCA is back. And the talk will fit nicely to the last talk that we heard, where it's about that we need to find a way to model more modular so that we can more easier in the community share our models. Also, I hope, between Brightway and OpenLCA. The headline is product category templates. I called these templates like that. It's a name I came up with. Maybe you know product category rules from EPDs. So why don't we have product category templates to model? Because we have seen already many good talks where people develop a new tool, but this is very specific. So this is usually then for one application and you need to use that tool. And on the other hand, maybe some of you who are in research projects, you start usually completely from scratch, right? And my pitch would be that we need something in between to help modeling. Just as a small introduction, there's companies like Zima Pro who now make configurable models in, I think it's Zima Pro Synergy. The problem is often these models are licensed, you know. This is, for example, for flowers, I think, a PEF-CR tool, and then you need to pay a license and so on. So it's not for open sharing inside the community. And it helps for this specific application. When you have money and you want to model flowers, you pay that license. But we need something that we want to share. Also, we have seen already yesterday a lot that, of course, Brightway has many configurable models. I took here the example of Parasol. I think Raphael yesterday gave a talk which is based on that. And it's a Brightway model. It's highly parameterized. That's really good. You can do a lot of calculations with it, but it's very specific. You know, you would not be able to use it in a different tool. And it is already connected to certain processes. And I want to make a step back, you know, like helping really the start of making a completely new model. So also at Green Delta, we have now online LCA, but this serves a different need of customers. It's similar to the slide I showed before. So we can tailor a certain tool for a certain company, but then this is only for that company. It can be private, it can be disclosed to the public with licensing and so on. But my idea I want to show here is product category templates. So it's like a modeling template, and you can connect it to OpenLCA, you can connect it to Brightway, you connect it to your database, and then you can still deploy it in an online web tool if you want to. And when we build such a product category template, the aim should be always, here's a nice quote, I like that, do everything as simple as possible, but not simpler. So how could we do that? Here are just some points how we can do it quite simple. So first of all, choose an open data format, right? Where there's only JSON-LD or ILCD, which hopefully all tools at one point can import and export. Then you put only the essential database elements inside, so not the whole background database, only your modules that you need for modeling or your parameters, maybe EPDs and so on. You can result, so I did it for a project, Hybrids, Horizon Europe project, which models PV systems. And this package can be only a few megabytes in size, which has all the modeling things you need. The product category templates I will show you, they have rigid base modules. They are always the same. They're following kind of the similar structures from EPDs. So here the functional unit is already fixed. For PV systems, this would be either kilowatt hours or watt peak. Then you have also additional sub-modules, which are then specific only to that subgroup for a PV system, for a battery system, hydrogen storage system, or other things. Very important, it's to reduce the parameters as much as possible. There should be a list of parameters, which is absolutely essential, so you need them. And then on top of that, you can have additional dependent parameters depending on how much you want to go into depth. But we should make a clear distinction between the two, because sometimes a tool is overloading the user with hundreds of parameters, and we should try to more categorize the things. What is really essential parameters and what is optional parameters to refine the model. Then in the best case, also the product category template includes already the impact methods that you want for a specific standard, a specific modeling guideline, which most of the time will be the EF 3.1 method. You can add additional methods which are only for that product category group. For example, for my PV systems, I add additional calculation methods for the energy payback time, material criticality, and things like that. We can also in OpenLCA include directly EPDs. Of course, EPDs, the quality of EPDs is quite varying. But sometimes when a certain product in your system is not your focus, you may be happy when an EPD exists. So it's good if it's already there, and then the user can decide if they want to connect an EPD to a certain product or not. And we can import and export them in OpenLCA. And we categorize the products, but I will show you that in a more better way. So here, summary again, you have the product category template, you include fixed modules, process, raw materials, transport, end of life, use phase. You have PCR specific modules in a PV system that would be maybe the front sheet, the back sheet, the absorber, the encapsulation, and all these things. You include the methods, you include specific calculation methods, you include harmonized locations, you include EPDs, all this in a very small data package in JSON-LD or ILCD format. And then you simply export it. And when we have this package in a zip file exported, it would be so nice if we can just use it in Activity Browser, in OpenLCA, or in other tools. Yeah, so these templates can be easily updated and improved. They are human readable, so you can use a simple editor. You can also connect it to a version control system like GitHub. We have also the LCA collaboration server for OpenLCA, which is based on Git. So there you can have a version control when you want to update the template. And yeah, you import it in OpenLCA or Brightway. After you imported it, you can deploy it in a web tool if you want to. You connect a background database like EcoInvent or the EF database. And of course, you need still to model. It's not that it's like a fixed tool where everything is there. You still need to model and add your primary data. So this is how it could look like. This is the base level. So this would be like the modules which are in every template, because they are always the same. This is the structure is simply taken from the EPD structure. Okay, you have here a PV system with the functional unit of a kilowatt hour. You have the product phase, the use phase, end of life phase, and benefits from consequential LCA. And then you have these other modules. But this stays the same. And it's only unit processes. You know, there's nothing inside. This is only to structurize everything, and that later you can make nice Senkai diagrams. Also imagine you have to review it. It's so easy to review such a template. Maybe you have ever gotten a model of a colleague and you try to understand it. It's sometimes really tough, right? So this would be then extended. You cannot read all this, but that's okay. So this was the base level, let's say, which is always the same. And then you have here additional modules, which are only for the PV system, for example. And you can easily cut away certain things depending on what you want to report, cradle to gate, cradle to grave. It stopped sharing. It's sensitive, okay. So here you can then say, okay, I only calculate this, so I only calculate cradle to gate if I want to. So it's like really modularizing all the things. And when you have these modules, it's so easy to have harmonized Senkai diagrams, Senki diagrams. Because here you can nicely see the levels. So this is the ground level, which has material, manufacturing, transport, end of life, and all these things. Then you have the next level, which is depending on your product group. This is a group level. So all PV systems will have maybe glass, production energy, and so on. And then you have the third level, which is dependent on your specific product. Which solar module are you using? Is it a thin film module, a silicon module? So you have a nice distribution of all these levels. Yeah, I said already reduce the parameters as much as possible, the less the merrier. Here for a PV system, that would be the absolute necessary parameters, but you can add on top as many as you want. You can even add parameter calculators. So you calculate your specific yield from the degradation rate, bifaciality factor, performance ratio, but this is optional. And this is the absolute necessary parameters. Also, what is possible in OpenLCA, it is then a bit like a tool inside the tool, because in OpenLCA you can select your providers, right? And when you categorize all your products to these modules, it's very easy to select what you want. For example, you can have very different glass sheets of different thickness with anti-reflective coating or not, and they all belong to the product of the front sheet. So you as a modeler, you just go into that process and then you click on the provider and then you choose, okay, do I want to have 2 millimeter glass or 4 millimeter and so on. And yeah, and all these products here, they are not real products. It's only that they are categorized. And then you're also not missing some things. Yeah, as I said already, we can also include EPDs. So in OpenLCA, you can now directly attach an EPD to a certain product as a provider. Just that you have seen it, for example, you want to model a module. You're not interested in modeling the inverter because you're not an expert in the inverter. So you take maybe an existing EPD from an inverter. But of course, be careful that it's all from the same program operator and that it's nicely modeled. Here, this is already the last slide, just to show you how easy it can be. This is OpenLCA completely empty. There's no database inside, nothing. I click Start. So you import EcoInvent as a background database, takes just a few seconds. You open it. You import now the template for photovoltaics in ILCD format, by the way. Can be also JSON-LD. It's importing now all the modules that I showed you. Then you can simply, you have different functional units. You can do a direct calculation. Of course, they are already pre-linked to some standard processes. I have not now changed here any parameters or any processes, and you have the results. You have the impact results here for certain indicators, contribution tree, where we said yesterday it would be good if we have a harmonized way of directly exporting this contribution tree. You also have the Senkai here, just to show you how quick it could be. Of course, you still have to do a lot of modeler work because you have to still model your primary data of how the what goes, for example, in the what's your wafer size and so on. So it's not taking away all your work. Okay, that's all. Thank you for your attention.
Thank you very much, Conrad. Are there any questions and discussion points you want to raise? Letting it sink first. Yes, we have Martin online. If you want to ask a question, if that wasn't an upload. Probably was.
Hello, hello. Martin, can you hear us?
Mix up to the upload sign with the raising the hand.
Otherwise,
Yes.
Romain?
Yeah.
Thank you. I think this is very good, actually. So what are the next steps that you envision to try to convince other LCA software developers to adopt this format and this template?
Yeah, that's a very good question. So first of all, we need to have one format that we can all import-export. Yeah. But maybe this is ILCD. I don't know, Chris will tomorrow talk about ILCD. So if we have solved this, it's already step one, right? Because all these template, it's simple, it's just unit processes which are connected, parameterized in modules. So you can simply put it in ILCD and re-import it. That would be step one, and step two would be putting this model into a public repository, maybe on GitHub. It can be also the collaboration server, which can be also public. And then people can commit changes if they maybe find something which they want to update, so that there's kind of one template which gets better over time.
Right.
And then, of course, the third step would be having more templates. So in my projects, I'm working currently on the PV template, and in another project where we have metal-organic frameworks, it's more like hydrogen storage systems. And then there could be maybe also battery storage systems. So I think the energy sector is maybe in the beginning, the most applicable one.
Yeah, and you can also imagine to have these EPD operators on board and to have some template that comply with certain PCRs.
Yes, yeah, absolutely.
Yeah.
Absolutely.
I think it's not in that same idea. I think there was someone who came last year at Brightcon. I wasn't there, but I knew he was there from Denmark, and he was trying to develop templates to do LCAs of buildings. And these templates, I think that he was using YAML files instead, and it was modular, and yeah, people just had to change quantities, but basically the modeling was kind of fixed. Of course, you had parameters, but it was an easy way of then being ingested by LCA Bug, I think. That's the building LCA software.
No, but absolutely, because this modular structure comes kind of from the EPD sector, so it could also serve EPDs that they are more harmonized. Of course, we have already tools doing that, but then the tool again is not disclosed to the public. It's with a license, and then you can only use this tool. Yeah.
There are more questions, I know, but for the sake of time, we have to continue with the next presentation. Thanks, Conrad, again. And our next speaker will be Hannes Schneider. Hannes studied process and environmental engineering, and he has been working for 4 years as a scientific assistant and doctoral candidate at the Institute for Chemical and Thermal Process Engineering at TU Braunschweig. He's part of the Sustainable Production Technologies Working Group, which fits perfectly to the sustainability aspect of this conference. And he's specializing in LCA of chemical production processes. And his talk will be about simulation-based creation of LCA datasets. Welcome, Hannes.
Okay, thank you. I don't know who read my abstract, which I wrote some months ago, but I wrote there that there's currently no available interface between LCA software and process simulation tools. And who was actually here yesterday knows that this is actually wrong, because Lukas Spiekermann presented his approach about alchemia. And there's also a poster from Matthias Schiedek. He will, I guess, present in the poster session right after this session. And there are even some more which came up in the last months and years. So what this actually shows is that there is a need for a better connection of process simulation and Brightway or LCA software. And this is actually why I also working on this topic. And today I would like to present you my work on the Simulin package, which is an interface between simulation models and Brightway. I first will give you an introduction why we actually need simulation software in LCA. Then I give you some insights in the Simulin package, how it's structured and how to use it. And afterwards, I prepared a small workshop where I go through a Jupyter notebook and show you how to use Simulin models. Okay, but before I start, I would like to define the term simulation software, how I use it in this presentation and in the package. When I talk about it, I mean a software which simulates any kind of flows like energy and material flows, which can be used to conduct an LCA. So as you may have recognized, this is a very generic definition, and it should be that this generic because the idea of Simulin is that it's not limited to specific simulation software. But as I'm a process engineer and I'm working with process simulation in my daily life, I would also give you some insights in the process simulation. Process simulation is actually a software which is based on thermodynamic models and material properties, and which can be used to simulate production processes in the material conversion industry, like chemical, pharma, or food. And some examples for these are Aspen Plus or ProSim from France and DWSim as an open source alternative. What they do have in common is that there is no natively support to LCA. As Lucas also showed yesterday, today's workflow to use it in LCA is to manually export it, transfer the data, and import it to LCA software. Yeah, but why do we actually need simulation software in LCA? Normally, we would prefer primary data, but of course, we have data gaps. In those cases, process simulation is actually a good high-quality data source compared to other alternatives. For example, for prospective assessment of technologies which are currently at a low technology readiness level, where we want to assess the technology at an industrial scale, but we don't have the data for this scale, so we can use process simulation there. In other cases, we probably use generic background data sets, but they have the disadvantage that they are static and discrete. So they reflect just one single scenario or sometimes a market average. And there we can use process simulation to generate, based on generic models, specific LCA data for specific cases. And this is where Simulin comes in. Simulin stands for Simulation Model Interface, and it's actually an interface between simulation software and Brightway 2.5. It's published under MIT's license. You can find it this repository and also on PyP. It's, as already mentioned, a generic approach, so not limited to specific simulation software. But this means also that the setup of the models needs a little bit more effort than in other approaches like this from Lucas, where you just drag and drop the Aspen model. But therefore, it allows also a lot of flexibility, which I will show you later. And it includes an automatic unit transformation by using the pin package, which were also already presented yesterday in the LCA break presentation. So now I would like to highlight two main capabilities. And the first one, which is probably obvious, is the automation of simulation-based LCA studies, which could be useful, for example, for prospective analysis or sensitivity analysis. But it could also help for sharing of models. For example, to publish the model used for LCA study as supplementary. What I'm planning to do, for example, for the work on a steam distribution model, which I show you off later in the workshop. And on the other hand, those models can easily be used by others in their own LCA study because they don't need to know how exactly the modeling framework works, as they don't need to handle the similar model. And it could be used for interdisciplinary collaboration. To give an example for this, I'm working in a project where we use reinforcement learning for process optimization in ecological objectives. And therefore, I could just pass the model and the LCA wrapped in the Simulin model to my project partner who's working on the reinforcement learning, and he can use it for his algorithms without need to know what I'm doing there in the models. On the next slide, I will give you some technical background of Simulin. So on the code base, it could be separated in three main parts. It's the SimModel class, which works as the model handler, the model interface class, which is kind of the Brightway handler, and so-called extractors, which are utility functions which can be used to extract data from specific software. So model class is an abstract class, and thereby some kind of generic wrapper for the model. And it contains, in the concrete implementation, the model initiation code, model solving, but can also store some metadata of the model. Then the model interface class is an identity class, which is useful for data validation and handles all those Brightway stuff like export to Brightway activity and also the LCA calculation. The extractors are scripts and functions which extract typical flows which you need from specific software, for example, the material and energy flows which are crossing the system boundary. And this is currently supported for DWSim and TestPy. Okay, now I would like to go to the Jupyter notebook where I show you the usage of one example simulation model, which is a steam distribution model I'm working on currently, which can be used for temperature-dependent process heat impact calculation for the chemical industry mostly. It's written in TestPy. It's a Python, open source Python package for thermal engineering systems. To install it, you can run locally pip install Simulin. There's also an environment prepared in the Jupyter Lab server, but currently you're not able to access eConvent there, so you can just follow there up to a certain step. But it's also, the material is uploaded, so you can download it locally and work there if you like to. Okay, here you can see the topology of this model. What you need to know here for today is that the big areas crossing the system boundary, actually those which can be assessed for the LCA, and that they are two functional units. This is produce electricity in the back pressure turbine, and the process heat used in a condensator. Currently it's handled as substitution, so the electricity is substituted by market average data sets, but this can adjust it how you like in the model setup. First, you need to import, of course, the packages and also the model in the background. Yeah. Then you need to initiate the concrete implemented sim model class, which is called here SteamNet, and provide a name for it. And then you can see that there are some references implemented. Currently, there are more like placeholders as it's not published yet. Also in short description of the model for which it can be used. Then the model need to be initiated, what is one of the first abstract classes, abstract method which need to be implemented in the concrete class. And now you can show which parameters you can adjust of the model. Here's a list of it. And when you initiate or when you calculate the model, you can pass the parameters you would like to change. Here you can also pass it as pinned quantities, but this is mostly because TestPy supports them natively. After this, you need to define the flows, which actually stores the flows in a technosphere dictionary and biosphere dictionary, which some relevant information regarding if it's a functional flow or it's a reference flow for the LCA calculation. And here you see already the calculated values. I mentioned that it's flexible to use these similar models. For example, here I implemented a plot of the temperature enthalpy diagram, which can be used for technical analysis or debugging of the model. The next step is to assign the Brightway datasets. So therefore, you need to first initiate the model interface class by passing the SimModel class. And then you need to do some Brightware stuff. We go over a little bit faster, defining methods and searching for some datasets which you would like to link there. And then by these methods at dataset, you can pass the link the datasets to the technosphere flows of the model. And then you have two options. You can directly export it to a Brightware dataset, or you perform an LCA calculation in the model class. We first calculate the background impact for faster computation. Then you can calculate the impact. And there you see, for example, for this impact category, the impact of the distributed stream. Yeah, this is another way to where it starts the impact. But you can also change reference unit. As shown here, the reference unit is megajoule, stored in the model unit property. But as it's supported by PINT, you can change the reference unit to whatever you like. In this example, I used kilo thermochemical British thermal unit. It just needs to be compatible with the default PINT units. Then you see the value is actually close, but not exactly the same. Okay, here I'll show you how to switch to allocation. There's in this specific model, it's implemented an allocation factor by exergy. I go a little bit faster over this. You need to create a new technosphere flow, remove the data set, and then you can calculate the impact. And you see there are two results here, one for the distributed steam and one for the produced electricity. Okay, to export it to Brightware, you just need to call the method export to BW, and you can pass a database name if you want to export it to a specific database. If not, it will create a new database called SimDB, and you can also pass an identifier. If not, it will create an own one based on the model name, the flow name, and the timestamp. Okay. Before I come to my end, I would give you some take-home message where this package might support you for your daily work. It could support interdisciplinary collaboration by interface between tools of different scientific fields. It can support a standardized and streamlined use of simulation models in LCA. And it could support fair sharing of models for LCA dataset generation. Okay, thank you for your attention. Here are some contact details and also the links to the GitHub repository and the PyP project. Thank you.
Thank you, Hannes. Lots of content to check once we will get home. Are there any questions, discussion points for Hannes? Yes.
Thank you for your presentation. How easy would it be to generalize your package to other models, including to models outside of industry, for instance, agricultural models?
Yeah, I didn't show it to you today because it would be a little more effort to do that. I mean, the idea is that you can use it for different models of every kind, but I'm only an expert in process engineering, so it's actually made for this. But we can probably get in touch if you're interested in this, and I will have a look if it's possible easily to implement also the models you need to use for that.
Something more you want to know? You want to discuss on this topic? Otherwise, I guess discussions will continue during breaks and later on in this conference. Also online, there's nothing. Okay, thank you very much, Hannes. Our next speaker is online, and I would like to welcome Luis Trujillo from Mexico. Luis, can you switch on your camera and microphone?
Hello? Yes, of course.
We can hear you already, that's great.
Okay.
But not see you yet. Perfect. Yeah,
Do you see me?
absolutely, perfectly. Yeah. Now
Okay.
you're sharing your screen. And I will introduce you while you're doing that. So Luis is an undergraduate math student. He's contributing to the development of the CREAA lifecycle database. And maybe you're going to tell us which LCA database that is and what it does. And his interests include data modeling, environmental informatics, and computational applications for sustainability analysis. We can see you well, hear you well, and also see the slides, Luis. So all is well said, and the floor is yours.
Okay, please tell me if you are able to see the presentation.
Yes, can you hear us?
Yes.
Yeah, we can see you, hear you, and see the slides. So feel free to start over. Can you hear us, Luis?
Yes.
Okay.
Yeah.
You can start.
Yeah. Thanks. Hello, everyone. I'm Luis, and today I'm going to present an automated systems that converts PDF documents into structured LCA data in minutes. By combining AI and open source tools, we reduce manual work by 80% while improving data quality. Let's dive into it. About CREA project. The CREA project, construction, waste, energy, water, food, developed at UNAM's Institute of Engineering, aims to build Mexico's first national life cycle assessment database. It supports evidence-based sustainable decision-making, enhances data quality and accessibility, and promotes circular economic strategies across key sectors. Well, the content. First one, the problem, the challenge of manual data extraction. Project objectives then, after that, the solution, presentation of the adaptive workflow, then the architecture and operation, a technical look at the heart of the system. We'll see an example, and finally, the future vision, the next steps. Okay, the challenge, manual LCA data extraction. Slow and tedious process, first hours of work of each document. Secondly, high risk of human error, inconsistencies in data transcription. And third one, lack of scalability, make it impossible to efficiently create large databases. Okay, what are project objectives? First and foremost, automate the extraction. We aim to fully integrate our N8N AI workflow directly into the CREA LCA database, moving completely away from manual processes. Secondly, standardize the information. Standardize Mexican life cycle data into JSON-LD interoperable formats. Our third goal, accelerate LCA creation, reduce manual work, and isolated data generation. And fourth, integrate into a functional ecosystem, enable transparent, validate, and participatory LCA data management. Okay, the solution, an automated and an adaptive ecosystem. From PDF to structured JSON-LD integrated directly into the CREA LCA database, ensuring consistency and interoperability across sectors. Here, you can see our workflow. PDFs are processed automatically through N8N, converted to JSON-LD format, and integrated into the CREA database by SQL. Before everything, what is N8N? It's an open source workflow automation platform that connects applications and services to automated repetitive tasks through a visual interface. Unlike other tools, it offers greater flexibility and is open source, which allows to self-hosting and total control over your data. The methodology. First and foremost, the input, the user uploads the PDF. Then the key decision, the workflow branches for thesis or proceedings. After that, parallel processing, customated routes for each document type, and finally, the consolidation. In this slides, you can see our complete workflow overview. And now we'll break it down step by step. The first stage, number 1, classification. This system identifies if the PDF is a thesis and routes accordingly. Then is the cleaning. A Python API removes unnecessary pages like covers and bibliographies. And finally, parallel extraction. Two nodes work seamlessly at the same time to extract text table structures. These prepare clean structured data for the AI analysis phase, which is the next one. This stage where multiply nodes work in coordination. The general info nodes use DeepSeek API to extract the study core metadata, including title, location, and key dates. The commentation node employs another DeepSeek API to identify specific methodologies and standards such as ISO. The actor node processes contributor information, extracting authors, supervisors, and their affiliate institutions. Each node focuses on different aspects of the document, working together to build a structured data profile. And finally, the inputs and outputs. On the input side, another DeepSeek API node identifies all resources entered into systems, material, energy, and resources like recording 150 kilograms of steel. At the same time, it catalogs all outputs leaving the system, including emission, products, and waste streams. The AI has been trained to recognize these specific data patterns. Now let's look at a concrete example. On the right side, we have the original PDF document, while on the left, we're showing the structured JSON output generated by our workflow. The system is automatically extracting and organizing key information such as dates, authors, institutions, and predefined sector classification. Now let's look at the inputs consuming the product. The system automatically extracts material like sodium carbonate and calcium carbonate from the PDF. It captures complete technical specifications, amounts, units, providers, and transportation details. And last one, for the outputs and emissions, the system identifies and quantifies all emissions like CO2 and HF. It captures amounts, units, and reference values for each. This enables accurate environment impact assessment and compliance tracking. Okay, future vision and next steps. Classify and validate national LCA datasets by sector. Integrate AI based uncertainty and confidence indicators. Then, foster collaboration with international patterns like Fraunhofer, Oko Institute, RISC, towards national, open, and validate LCA database for Mexico. This is our team, and below you can see our emails if you want to contact. Thank you so much.
Thank you very much. We have questions in the audience and also online. The first question online was, where can we find actually this database? Is it already somewhere findable?
Yes, you can see the database.
So it's somewhere, if we Google it or with a link, then we will find the link.
Yeah. Give me a moment and I'm going to send this link by the chat.
Perfect. Thank you very much. And then we have questions in the room.
Thank you for the presentation. This was very promising. I was wondering if you're connected to Hestia, who's been working on also automatization and data gaps, because in many publications there are some data gaps. And I feel like if you combine your approach with the data gap filling of Hestia, that could be super powerful.
Can you repeat, please?
Yeah, I was wondering if you are aware or connected to the Hestia platform. It's a platform, it's only on agriculture LCA, but it's specialized on data gap filling based on scientific publication, from what I know. And so I was thinking that because in many publications there are data gaps, and so if you could combine your approach with the data gap filling of Hestia, it could be a very powerful way to create new data sets.
Okay, Hestia. I think no. Actually, I think no. But it sounds really interesting to consider and see how we can integrate our data and our approach, and yeah, and see the results.
Hello, can you hear me? Okay, great. Thanks for the presentation. I have a question. I think it's a bit similar to the previous speaker. Are you aware about the work that Tiangong doing with respect to the validation of their data and generation of the data sets based on the Chinese industrial data sources? It seems like they are at least partly doing the same thing that you're doing, and I assume the underlying flow could show a lot of similarities, like you're using DeepSeek, which is prohibited in European Union, of course, Western world in general, but of course in China, that would be also the basis for the AI agent. So maybe you could also explain like a bit how are you connected, if you are connected, and yeah, future collaboration maybe.
Okay, DeepSeek. Yeah, we connected. We connected DeepSeek and by NAN. This is a platform. Maybe we can use another AI model in the future And what else? And at the same time at local, working on local, working at local AI. And what else? What else? But we are still under development. Right now, we're still under development. Yeah, it's not a final version.
Thank you very much. So there's lots of opportunities to actually connect and bring things together with what you presented. So that's interesting. If it's not going to be too late for you over there in Mexico, maybe you want us to join us for the panel discussion. There will be Tiangong present, and also others. So lots of opportunities for collaboration for you. Thank you very much again, Luis, for being with us and presenting.
Thank you. Thank you so much.
So, not yet lunchtime, but soon. So what we're going to do now is having a 20 minutes discussion session. And after that, we will have 5 poster spotlights because we will have lunch soon. And this is an appetizer, not only for lunch, but also for the posters which are presented out there today. So this is what we are doing now. So, and I know that if I'm now going to ask you, what do you want to discuss? And do you have keywords? Nobody will speak up. I know how you are. So what we are going to do now on site and also online is we are going to form small groups just with your neighbors around and just exchange a bit. So you are going to exchange on some questions which I can give to you now. And the idea is really to share your thoughts. What have I heard? Was there something which excited me? I hope so, that you heard something which was exciting. I'll give you the questions right now. We can see my screen at some point. So we'll do that for roughly 10 minutes, then come back to the plenary for another 10 minutes to share what you have discussed. And after that, we will have the poster spotlights. And after that, there is a task for you. During lunch break, please try to speak to a person to whom you have not yet talked in this conference. So during lunch break, absolutely make sure to talk to someone you have not yet met and just exchange a few words of how was the conference for you? How was it? What was the relevance for your work? And exchange on that. Okay. Yeah. Is it kind of? This is just to give you some ideas. Of course, you feel free to discuss whatever you want. So something which excited you, are there some keywords which stick to your mind? Were you surprised about something? Or was there something you had already tried to do, but you didn't succeed, or you succeeded and you want to follow up on that? Or there were 2 similar approaches, because we deliberately had placed some presentations together which tried to solve similar things. And it would be interesting to see what are the differences and how did they approach that? And then also thinking about a topic which you would like to discuss more in depth. So we start over. For those on site, just form little groups with your neighbors. For those on site, Xiaojin is also with you, but leave the room and just proceed to one of the group tables and then just start exchanging, and we will back in 10 minutes to the plenary. Wish you good discussions.
Hello, everyone in the plenary room. Please just click the button at the bottom on the right-hand side. There's a button on there's like a door sign that just click that button, and then you can leave this room and just move to the lower left side where there's a green area with a lot of group tables. There you can just approach one table and form groups, and we can discuss there. I will be meeting you over there. So see you later. So afterwards, I have to show PDFs. I got it. Hello, for those who are here and who are still sitting next to the desk, we are having some groups over the lower left bottom. So maybe if you want to join the discussion, just go there. We are chatting over there. So see you there. Come back to your desk. Okay.
So I appreciate that there are intense discussions. That's great to hear and see. Also online, they have been together and they are now coming back to the plenary. Moving back, I see them. Is there anything someone wants to share from these discussions? If you want, if you have identified something which you want the plenary to know. Okay, that's why I made the groups discussions. Yes, but Paul.
Yeah, I think it's really interesting by the design of the session to make apparent that we are a lot working on similar topics and not knowing each other. So maybe that should be an incitation to actually design a way to work together for the next period of time to set up common solutions, for example, the TA-LCA relationship and so on. Try to link up the different works that have been done to a common solution, for example.
Calls like for some type of platform where we actually make aware that we are working on something and others can also see it. There are all these GitHub repos, but I mean, you don't always find them. Findable. Yeah, great input. Anything else?
Actually, okay. I just wanted to comment on the previous speaker. Basically, the part here could fit in that role, actually. So a lot of the things that Chris was speaking about touches upon the visibility, forming of the working groups. So yeah, I can definitely see a lot of overlaps.
Yeah, yes, I mean, Départ de Sentier definitely wants to become a hub, an incubator for such ideas. So, yeah. So we will have a board meeting soon and also decide on our strategy, what do you want to do. There's a general assembly tonight for all those who are members of Départ de Sentier. And of course, Départ de Sentier is not, we don't do things for you. As I say, I think we should become a facilitator and an incubator of what is needed. So members and everyone should also tell us what is needed. And I think this conference is a great place to realize what are the needs of the community to move ahead. Is there anything online? Anyone maybe who wants to share something? No? Otherwise, we would continue with our last agenda point before lunch, which are the short poster spotlights. We made poster spotlights because I think it's always a pity if posters are just hanging around. I think it's that they are great posters and it's of value to quickly tell the people what they can expect and make them aware that they should come to your poster because it's a nice one. And that's why we have this poster spotlight. So I would like to ask all the poster authors to come here, just really all directly together. I will share the PDFs or the slides you have sent to me, and then we just go row by row. You know, it's 2 to 3 minutes. The idea is really to just quickly show the people what to expect when they come to your poster. I'll quickly set up the PDF. I need to share. Perfect, you're there. Yes. Can we just do it?
Yeah, sure. Oh, I was not prepared to be the first one. Hi, I'm Saara Saukkonen from the Finnish Environment Institute, and I have a poster here about our case study that we are now doing with Brightway. It's our very first baby step. We've been looking to learn how to use Brightway and Activity Browser for a few years now, but our problem has been with the technical know-how, and then I said that I know some coding, I've been doing some Python, and then they were like, perfect, you go and learn and teach us. So I'm here, this is our very first steps, and we are like looking to get inspired and learn from you, and I've been very like impressed with all the presentations now, and I hope that I learn some more and get inspired. This is the very baby steps, so I'm not sure. You can go and see what we have done, and then tell me what we should actually be doing, how we can use all those advanced features that are available. I think that's it.
Thank you very much, Sarah.
Hello everyone, I'm Adrien. I work at the Grenoble Electrical Engineering Lab, which is 200 meters far from here. I work as an associate professor, and I do some research on the trade-offs in designs of electrical systems, and more precisely, this work is about locally manufactured small wind turbine. So I'm part of a global network, a community, which design and build locally manufactured small wind turbines for sustainable rural electrification. The model is open source. And within the community, there were some questions about design trade-offs. Should I use neodymium magnets for my generator? Should I put a small wind turbine rotor on a tall mast or a large rotor on a small mast? So we built some model to try to answer that by connecting some energy models and some LCA models. And if you want to have the answer about the tall mast and the rotor size, you can come to my poster and I will show you some of the insights. Thank you.
Good morning, everyone. My name is Carlos Hernandez. I'm a PhD student at the University of Coimbra in Portugal. My poster is about a case study from the automotive industry. It's basically the co-design of an automotive company. It's a internal door handle, which is, this is a prototype of this automotive company, which is supposed to be in battery electric vehicle. And the main question in this poster is like about the use phase of this automotive component when we compare like different materials, for instance, polymer biocomposites and ultra lightweight material like carbon fiber and glass fiber complex. So the idea is what's the best decision making that we could take when we take in account, for instance, the energy transition in the use phase modeling. So yeah, this is my poster, this is the subject. So thank you.
Thank you very much.
It's animation, but you can just keep it like this. Okay. So hi everyone, I'm Matthias. I'm a chemical engineer from Forschungszentrum Jülich, and I'm also working as some others here on the coupling between process simulation software and assessment tools, for example, life cycle assessment. So chemical engineers really like to vary process level parameters like temperature or pressure, and then investigate how the process behaves in terms of efficiency. But some of these parameters actually go beyond the process simulators and cannot fully be captured by them. Let's take, for example, the operating temperature of a PEM electrolyzer. If we increase the temperature, efficiency goes up because kinetics speed up. This is great because we need less electricity for the same amount of hydrogen. But on the other hand, the membrane lifetime is negatively impacted by the higher temperature. So we kind of have an economic and also an environmental impact by this, which we need to consider before we actually build such a plant. So to know about it, to get a feeling what this actually means. And for this, I developed a Python-based framework that couples process simulation or one specific process simulator to techno-economic assessment and life cycle assessment. The data from the processes are structured into building blocks to ensure a consistent system boundary and also the same functional unit for both assessments. And we can then assess the operating part of this parameter variation and also the investment aspect of it. Yeah, as I said, my goal is to enable a parametric view of things. And if you want to find out more about this framework, how it's structured and how it works, then I would be very happy to welcome you at my poster outside. Thanks.
Last but not least.
I guess I can start already. Hi everyone, I'm Fabian, PhD student from Aachen, where our research group performs LCAs on various energy and process systems. So even though we all do quite similar things, collaboration could be better. So right now the problem is that every researcher builds their own models. Some use Brightway, some use other tools, but those models are usually not shared within the group. So that's quite inefficient, you can see. So our idea is to build a shared cloud-based database so models can be shared with colleagues and can reuse if that's interesting in follow-up projects. We're in a very early stage of that, so we brought a poster with our basic idea and our requirements, and we're very happy for your input and your experience on that topic and discuss possible solutions for that. Thank you very much.
Thank you all. And yeah, looking forward to checking the posters. The posters are also online on HiHive in the poster corner. If you want, the online audience wants to watch them there, feel also free to contact the poster authors if we have questions online. And otherwise, we are set for lunch. Thank you for this great morning. Thanks to the speakers. To all speakers of this morning, we will start over at 1. And please don't forget the little task. Talk to at least one person you have not yet exchanged with during this conference. Enjoy. Should I switch it off? We just keep it as it is.
B cable. Like a cheap USB cable doesn't work well. I don't know if this one's any better, but we can try to change it. I tried turning down the gain here. This was quite high.